Sequence activities. The sequence activities process puts the activities in the order they need to be performed. This process is not concerned with when the activities will occur on the project timeline, just in what order. Properly sequencing activities involves determining the dependencies and relationships between activities and applying leads and lags. Activity sequences are shown through project schedule network diagrams, which schematics are showing the order and relationships of project activities. Sequence activities. Inputs. Activity list. The activity list is the complete list of project activities that are needed to produce the work packages. It's decomposed from the WBS work packages. The source document. This process needs to identify what the activities are that need sequenced. Activity attributes. The activity attributes document is a companion to the activity list. It provides sufficient detail to fully describe the activity, and any supplementary information about activity, such as its relationships, constraints, assumptions, dependencies, and responsible people. Milestone list. The milestone list contains all project milestones regardless of where they originated and whether the milestone is optional or mandatory. Milestones can originate from the customer, performing organization, project manager, or project team. Milestones can generate dependencies and relationships between activities and might necessitate the need for leads and lags. Project scope statement. The product scope describes the characteristics and functionality of the product, service, or result. Compared to the project scope, it is more focused on explaining what the product will be and how it will be used. The scope statement may identify constraints that will generate dependencies and relationships between activities and might necessitate the need for leads and lags. Organizational process assets. Organizational process assets are the source of existing policies, processes, organizational data and knowledge. These assets include the entire collection of formal and informal methodologies, policies, procedures, plans, and guidelines, as well as the organization's knowledge base, which includes historical performance data. Of use to sequencing activities could be data from prior projects. Sequence activities. Tools and techniques. Precedence diagramming method PDM. A method for producing project schedule network diagrams. PDM produces activity on node AON diagrams. These are schematics that show activity sequencing and relationships and are used in the critical path methodology CPM. PDM includes 4 types of dependencies or logical relationships. Finish to start FS. The initiation of the successor activity depends upon the completion of the predecessor activity. Finish to finish FF. The completion of the successor activity depends upon the completion of the predecessor activity. Start to start SS. The initiation of the successor activity depends upon the initiation of the predecessor activity. Start to finish SF. The completion of the successor activity depends upon the initiation of the predecessor activity. In PDM, finish to start is the most commonly used type of precedence relationship. The start-to-finish relationship is rarely used but is included here for a complete list of the PDM relationship types. Dependency determination. When they exist, dependencies between activities can be mandatory, discretionary, or external. Mandatory dependencies are dictated by contract or the nature of the work. Discretionary dependencies are a preferred sequence. And external dependencies are those controlled by factors outside the project. Applying leads and lags. Leads and lags are needed in the schedule for a variety of reasons, such as dependencies between activities. Leads cause two activities to occur for some period of time in parallel when they'd normally have been sequential. Lags cause a delay between the finish of one activity and the start of the successor activity. Scheduled network template. Templates can be helpful to decrease the time needed to create a project network diagram. Sequence activities. Outputs. Project scheduled network diagram. Project scheduled network diagrams (PMP) are schematics that show the sequencing of activities and activity interrelationships. The two types of diagrams are activity on arrow AOA and activity on node AON. Project document updates. Sequencing of activities will usually result in updates to one or more other project documents. Activity dependencies. Dependencies restrict the order in which activities can be performed. Dependencies should be described when they exist, usually on the activity attributes document as well as through narratives on the project scheduled network diagram or through a supplementary document to the diagram. There are three types of dependencies. Mandatory. A required, hard logic, or inherent order to the activities. For example, a book can't be bound until it has been printed. Mandatory dependencies can also be caused by regulatory requirements or organizational procedures. Mandatory dependencies cannot be altered, they are what they are and the project has to adhere to those dependencies. Discretionary. A logical or preferred order to the activities. For example, in a remodeling project the team would prefer that carpeting not be installed until all painting has been completed. Discretionary dependencies can be reordered if necessary, but doing so may result in additional risk factors. External. The dependency is outside of the project and usually beyond its direct control. For example, a technician can't begin installing the equipment until the vendor delivers it. Though sometimes external dependencies can be influenced or made contractual, such as with a vendor or consultant, they can usually be altered. External dependencies can also lead to scheduling problems when no hard date is available. For example, some modes of transportation can provide only a date range of when materials can be expected to arrive. Activity relationships. Activity relationships are another restriction that affect the order of activities by establishing the start and finish relationships between successor and predecessor activities. If there is any unusual logic to the relationships, it should be documented on the activity attributes document as well as through narratives on the project scheduled network diagram or on a supplementary document to the diagram. There are four types of activity precedence relationships. Finish to start FS. The successor activity can begin only after the predecessor activity is completed. Activity B can't start until activity A is completed. This is the most common type of relationship. For example, a house's concrete foundation can't be poured until the excavation activity is fully completed. Finish to finish FF. The completion of the successor activity depends upon the completion of the predecessor activity. Activity B can't finish until activity A is finished. This relationship is necessary when both activities need to finish at the same time or very close to each other, but there's not any relationship between the activity start dates. For example, in order to be ready for binding, the cover of a book needs completed around the same time as the printing of the book pages are done. Start to start SS. The successor activity can't start until the predecessor activity starts. Activity B can't start until activity A has started. This relationship is needed when the starting dates of the activities are dependent upon each other, but the ending dates are not. For example, Survey responses can start being tabulated as soon as the survey results begin coming in, since there's no real need to wait until all survey results have been returned before entering them into a database. Start to finish SF. The completion of the successor activity depends upon the predecessor activity. Starting activity B can't complete until activity A has started. For example, in a project in which equipment is being replaced, before the old equipment can be fully decommissioned, activity B, the initial testing of the new equipment, should have been successfully started. Activity A. The testing does not need to be fully completed, but just far enough along that the team can be assured the new equipment is functioning before the old equipment is dismantled. Leads and lags. Leads and lags are artificial effects on the timing of activities and are used in conjunction with activity relationships and dependencies. Leads and lags and the reasoning behind their use should be well documented, because it may not be obvious to the casual observer why they were established. Lags are delays or waiting time between activities. For example, if a parking lot is being resurfaced and there is a 24-hour curing period for asphalt before stripping can begin, there would be a one-day lag between these activities used in conjunction with a finish-to-start relationship. Activity B, stripping, can't begin until one day after activity A, asphalting, is completed. We can think of lag as positive time added to an activity's duration. If the asphalting task takes 2 days and there's a one-day lag while waiting for it to cure, the duration of the asphalt activity is 3 days. Leads speed up activities without changing the relationships between the activities. We can think of leads as a gate of IM because they allow activities to occur in parallel that would normally be done sequentially. For example, after the parking lot has been resurfaced with asphalt and the painting of parking spaces begun, inserting the signs for handicapped spaces could start even though stripping of the spaces is and done. Activity C, posting handicapped parking spaces, will begin one day before activity B, stripping, is scheduled to be completed. Leads can lead to rework and usually pose other risk factors as well, so they should be used carefully. Project Schedule Network Diagrams. Project Schedule Network Diagrams, sometimes referred to by the acronym PMP, graphically show the relationships, sequences, and durations of all activities from the start to the end of the project. These diagrams are an integral part of the scheduling process and are necessary for determining the critical path of the project. Most project management software applications will produce project schedule network diagrams, but we should know how to read them and create them by hand for the PMP examination. Though time-consuming, producing them by hand, even if only at a summary level, has the added benefit of often uncovering missed activities, incorrectly sequenced, or erroneous relationships between activities. There are two types of network diagrams: the arrow diagramming method known as ADM and the precedence diagramming method PDM. For now we're only concerned with properly sequencing the activities and don't need to worry too much about the diagrams. Later on during the Develop Schedule process section 6.5, we'll spend more time with these diagrams as we add activity durations, calculate float, and use them to determine the project's critical path. The arrow diagramming method ADM creates diagrams known as activity on arrow AOA. This is because ADM diagrams use activities shown on arrows and connected by nodes, usually shown as circles. ADM is the oldest diagramming method, and is now infrequently used. Its drawback is that it can only show finish-to-start FS relationships. In order to show relationships between tasks on different node branches, ADM diagrams use dummy activities. These are fictional activities shown as dotted lines with duration of 0 that join nodes. In the example diagram to the right, A dummy activity between E and C indicates that there's a finish-to-start relationship. Activity C can't begin until activity E has been completed. The precedence diagramming method PDM creates diagrams known as activity on node AON. It uses nodes, usually shown as squares, to hold the activities which are connected by arrows to show the relationships. The PDM diagram is the one most commonly used because it's more flexible and can show any activity relationship.